to the channel. I hope all of you are doing grateful today. आज हामी यहाँ सुरुमा रहेको छ न्युमेरिकल मेथड हेर्नेछौँ। प्रोजेक्ट रहेको रहेछ डिबिएमएसको रहेको रहेछ। आज हामी न्युमेरिकल मेथड हेर्छौँ। Okay, now let's begin the node way. No. Simpson 3/8 rules छ सुरुमा। Okay, observe all the difference of higher than the third will become 0 and we obtain x0, x3 by dx, 3x y0, 3 by 2. यो setting n is equal to 3 in the general formula, we observe all the difference higher than the third will become 0 and we obtain similarly a composite trapezoidal rule. If the area to be integrated is larger than the trapezoidal rule can be improved by dividing the interval AB into a number of small interval and applying the rule. The sum area of all the sub-interval is the integral of the interval AB. This approach is also known as the composite multi-segment approach. And a total area of the segment n minus 1 s2 f0 fx2 s2 fx fx2 s2 fx n minus 1 fx, which is the general form of the composite trapezoidal rule. Applying the Simpson 1 by 3 rule to calculate sin x dx with k6, here is the given equation. न्युमेरिकल मेथडमा पढ्ने जस्तो खासै केही पनि छैन जस्तो लाग्यो। बरु हामी यहाँको रहेछ the element of the matrix are the conceptual row by row in order indicated in the figure. The circle of the number is indicated the order of the computer and the arrow indicate the dependency of the element. An element is a head depend on the element at the tail end. The first column of this matrix contains the element of the integral obtained by the recursive trapezoidal formula with decreasing value of step side explicitly n minus 0 is the result of applying the trapezoidal with 2n equals to the sub-interval. The first term of them R00 is obtained just with the one trapezoidal. Similarly, R1, 0 is obtained with the trapezoidal and so on. Element in first column represent the trapezoidal rule as1, as2, as4, etc. They can be evaluated recursively as b minus a R00 as by 2 fa plus fb r I1 0 where hi b minus a 2i k is equal to a plus k hi r I j 4 j I j minus 1 r I j minus 1 j minus 1 4j is called the Romberg integral formula. Compute the following Romberg integration estimate R2 for एमा खासै अझै अब फेरि अहिले लास्ट टाइम आउँछ होला पढ्ने पर्ने कुरा यहाँ रहेको रहेछ solution of ordinary differential equation. Mathematical models which use the differential calculus to express the relationship between the variable are known as the differential equation. The differential equation may appear in the different form number of independent variable. The quality being differentiated is called the independent variable. The quality with respect to which the dependent variable is differentiated. If there is one independent variable, the equation is called an ordinary equation. If there is more than one independent variable, the equation is called the partial differential equation. dv dt minus km dv square dm dt minus km 0 ordinary d0 n dx square du square v dv square fxy partial differential equation. Order of the equation: the order of the differential equation is the highest derivative that appears in the equation when the equation only contains a first derivative of that is called the first order differential equation. Of the highest derivative is the second derivative of the equation, which is called the second order differential equation. Dy by dx xy order 1 fy x I double 11 order 2 m d square y dt square x dy dt plus ky 0 order 2. Degree of the equation: the degree and the of a differential equation is the power of the highest order derivative x y1 y2 y1 2y plus 3 degree minus 1 order 2 y11 xy 0 degree 2 order 3. Initial problem versus boundary value problem. The solution of an ordinary differential equation requires auxiliary condition for an order equation, and condition are required if all the condition are specified at the same value of independent variable. Then the problem is initial value problem. Example eny if the condition are known as the different value of the independent variable at the extreme point or the boundary of the system, then the position is known as boundary value problems. Solving the initial value problems Taylor series, we expands we expansion of the function yx that of point x0 using a Taylor series expansion yx y0 x0 y1 x0 x0 t square y1 0 2. Solve y1 x square plus y square under the condition yx1 when x0 y1 x square plus y square 2x 2 y1, and substituting the value in the Taylor series yx y0 x minus x0 y1 x0 y1 11 x0 x0 y11 x0 y3 x0. Solve the differential equation substituting the value in the Taylor series xy y0 x0 y1 x0 y0 x0 y11 0 by 3. Piscard method: considering the differential equation y dy by dx f xy, we can integrate this equation to obtain the solution of interval x0 x dy by dx y0 minus y0. Since y appears under the integral sign of the right side of integration cannot be performed, the dependent variable y should be replaced by either a constant or fx. Since we know that initial value of x equals to x0, we may use this as the first approximation to be the solution of, and the result can be used on the right hand side to obtain the next approximation y0 and xy0 dx in general x y10 x minus 1 dx. Solve the equation using the Piscard method with the initial condition y0. Find the value y0.2. Correct up to the second approximation y1 x square plus y square y0 x00 y10 x0 z y10. योमा खासै पढ्ने कुराहरू त्यति धेरै रहेन रहेछ। अब हामी आएको डिबिएमएस पढौँ है त। डिबिएमएसमा पढेको कुराहरू मैले बुझाइदिनेछु हजुरहरूलाई।